there. So that's information gathering. We've gathered our information. It's important though to draw a line somewhere. You can gather all this information, and you need to know when to stop. Right? You don't really need to know how many door handles there are or how many nails are used in the plasterboard. That's going too far. We could keep on modeling over and over and over and gathering all this information, but it's going to make negligible difference to the overall results. And there's some defined rules for that. And let's just go full screen here. And that's what we call the cutoff criteria. And it enables you to complete an LCA practically without going into levels of detail that are completely unnecessary and not going to influence the results or influence, at the end of the day, the design. We want to be improving the designs and worrying about little things that don't make any impact on the environmental performance aren't worth including or spending too much time on. So the cutoff rule, generally, if a mass is greater than 1% of the total, you want to include it. If an energy flow is greater than 1%, you want to include it. And if the sum of the neglected flows, we call them, should always be less than 5% of the total wherever possible. Most important one that I like to consider is the environmental relevance. Kilograms of CO2 is going to be less than 1% of the total. Well, it's not really influencing my LCA that much. Now, there's a kind of paradox there in that you have to model this thing to understand whether it's less than 1% or greater than 1%. By the time you modeled it, well, you might as well, it's already included in the model essentially. So, but what we do is this kind of approach where we keep on modeling as much as practically possible, and then run a test. Say, okay, we've gone this far. These things are all less than 1%. So we're pretty confident that we have covered off on everything that's within the cutoff rules. And just as an example here from an LCA that we've completed, here are all the materials that went into this large commercial office. So yeah, concrete in windows, most significant in terms of environmental relevance. We're looking at percentage of the carbon in each of these materials make up. Down there you've got things like laptop stands, urinals, scaffolding, and they're down at well less than 0.1%. So we know we're well within the cutoff rules. It's unlikely that there's anything that we've missed out that is going to be greater than the cutoff rules that we should have included. It's possible that you've completely forgotten about something major, but pretty unlikely given that you've managed to include all of these other things that are well below the cutoff rules and really making insignificant impact on the overall results. That's also just looking at the embodied carbon. This is an LCA, so we will be looking at the energy as well and the water. And when you include that, the proportions of these materials make up of the total becomes even less. And really negligible impacts from some of these smaller things that we've included. Was it difficult to include them? We're using our template approach that we'll see in a minute. So we might as well, we pop them in anyway, but yeah, they're well above those cutoff rules that are defined by the standards, by EN 15978, which is your global standard in buildings LCA. Little note there, on this kind of paradox that I mentioned, and the important thing is to maintain be pragmatic about it, be sensible, don't spend all your time chasing information that's not going to influence the results. Is the key message there. Here's a quote from John Maynard Keynes, and something that we stand by fairly rigorously when we're running LCAs. We really want to focus our attention on the recommendations, on the reporting, on presenting the results to clients, get that model together nice and efficiently. And so it's better to be vaguely right than precisely wrong. If you're not sure about something, make some assumptions, plug it into the tool, see how much of a difference it makes. We didn't go out and find loads of information on a laptop stand. We probably, in this case, just made some assumptions. Maybe a couple of kilograms of plastic for a laptop stand times number of occupants, and yeah, it's a vaguely right answer rather than precisely wrong. And when we throw that into the model, we see that actually it doesn't make much difference to the overall results anyway. If we'd got that laptop stand figure wrong by 50%, it's still going to make minimal impact on the overall results for the fittings or for the overall LCA. So yeah, that's our kind of mantra. We stand by when we're building LCAs, better to be vaguely right than precisely wrong. So with that all in mind, let's jump into the software.